Good morning, students. Today we are going to start with extraction of aluminium. As you all know, the chemical symbol of aluminium is Al. The atomic number is 13. It belongs to period 3, group 3A or 13. Aluminium is the most abundant metal in the Earth's crust. The chief ore, or you can call it the principal ore of aluminium, is bauxite. The formula is Al2O3.2H2O. Now there are two steps involved during the extraction of aluminium from its ore bauxite. First step is concentration of the ore, or you call it purification of ore, by Beer's process. In it, there are three reactions taking place. The first one is the conversion of impure bauxite to sodium meta-aluminate. You react bauxite with sodium hydroxide solution, concentrated solution, at a temperature of 150 degrees to 200 degrees Celsius. You obtain sodium meta-aluminate, which is soluble in water and water. So you have converted an insoluble compound into water-soluble compound. Next is conversion of sodium meta-aluminate to aluminium hydroxide. I diluted with water at a temperature of around 50 to 60 degrees Celsius. The products are sodium hydroxide and a white precipitate of aluminium hydroxide is formed. I will filter it, wash it, and then dry it. Now, this aluminium hydroxide is heated to a high temperature, say around 1100 degrees Celsius. You get alumina, that is aluminium oxide, plus water vapor. So these are the three reactions taking place during purification of ore by Beer's process. Now we move on to electrolytic reduction of fused alumina by Herrol's process. Step 2 is electrolytic reduction of fused alumina by Herrol's process. The electrolyte is a mixture of molten alumina 20%, cryolite is 60%, and fluorspar is 20%. A thin layer of powdered coke is sprinkled over the surface of the electrolyte. Why? Because it prevents the burning of carbon electrodes. It prevents heat loss by radiation. Now let us take a look at the diagram. You see there are a number of carbon or graphite anodes, and the electrolytic cell is made up of iron tank. Internally it is lined by a thin carbon lining, which serves as the cathode, and these graphite rods, it serves as the anode. There is a tap or a hole there to collect the molten aluminium. It is heated electrically to a temperature of 950 degrees Celsius. Current 100 amperes at 6 to 7 volts. Now let us take a look at the reactions. Cryolite dissociates into sodium ions, aluminium ions, and fluoride ions. Fluorspar, it dissociates into calcium ions and fluoride ions. And aluminium oxide gives aluminium ions and oxide ions. The reaction taking place at the cathode. Aluminium ions will gain electrons from the cathode and get discharged, so aluminium is being deposited at the cathode. At the anode, you'll see that the oxide, it loses electrons and it forms oxygen gas. Now, this oxygen gas, it will oxidize the carbon anodes. So the carbon anode gets oxidized to carbon monoxide, which burns with a light blue flame, giving carbon dioxide. Hence, the carbon anodes need to be replaced periodically. Now, why have you added cryolite? Cryolite, the formula is Na3AlF6. It lowers the fusion temperature from 2050 to 950 degree Celsius, and it also enhances the conductivity. With this, we come to the end of electrolytic reduction of alumina by Herrol's process. You have to revise both the processes, that is Bayer's process and Herrol's process, and learn the equations by heart. Thank you.